Neural networks are learning devices that were inspired by the brain. In the 1980s, there was a lot of excitement about neural networks because we discovered the backpropagation algorithm, which allowed neural networks to learn lots of layers of nonlinear feature detectors. Potentially, this should have made them very good at things like speech recognition and object recognition. But in fact, computers were a bit too slow back then. Since then, we've improved the learning algorithms and computers have got a lot faster. And now neural networks are very powerful learning devices that are extremely good at things like speech recognition and object recognition. In the course, you'll learn a lot about all sorts of different neural networks, but perhaps the best way to get a feel for it is by a little demonstration of a neural network recognizing handwritten digits. Okay, so this is a picture of a neural net. It's got a place where it gets its input, these are pixels, and it's got 3 hidden layers here, and these are going to learn to be feature detectors. And then it's got some outputs here where it says what class it thinks this digit is. So the classes are arranged like this. There's 10 different categories a digit can be. This neural network was learned in an interesting way. The feature detectors here in the first hidden layer learn to find common patterns in the input without yet knowing anything about what the task is. And then these feature detectors here learn to find common patterns among these feature detectors. And then finally, the feature detectors at the top here learn to find common patterns among these feature detectors and among the labels. So when we learn the top level here, we tell it what the labels are. And after it's learned, it can recognize digits. So we've given it this digit, and we'll tell it to try and recognize it. And you'll see it running through and recognizing the digit. I'll run that same thing slower. So here we go again. And you'll see that these neurons are behaving erratically. They're probabilistic neurons, and that's actually important to this learning algorithm. And so each time we give it the same input, different neurons get active. Some will have more tendency to get active than others, but nevertheless it always recognizes the pattern correctly. So this is an example of a probabilistic neural network giving very reliable behavior. Just to show you what happens with a different digit, we'll give it a different input, and hopefully it'll recognize that it's different. So now it recognizes that it's 5. Okay, that's one thing this net can do. And like I said, it was trained by training these feature detectors to model what's going on in the layer below. And then there was a final stage of training when we trained everything up all together to work nicely. All of this will become clear by the end of the course. There's something else this net can do, which is it can imagine digits. So if we, for example, say, I want you to imagine a 2, so I clicked on 2 here, and it's going to fix this to 2, then the weights that it's learned between this neuron here that represents 2 and all of these 2,000 feature detectors here, those weights will now be trying to turn on certain feature detectors and turn off other ones. And then these feature detectors will be trying to turn on certain ones of these 500 feature detectors. And this whole system of 2,000 here and 500 here can rattle around and settle into nice happy states it's stable with. And those form a ravine, and when I put a 2 here, it's a ravine in which it represents 2s, and different 2s are different places in that ravine. If I put an H here, it'll be a different ravine. So let's run it backwards, getting it to fantasize 2s. So what's happening now is it's going backwards and forwards here, and each time it produces a new pattern of features here, it shows you what pixels they would turn on. If we run it faster, you'll see that after a while it falls into the ravine for 2s, and now it's going to generate 2s, and it's going to generate lots of different kinds of 2s. And so you can see it understands a lot about 2s and all the different varieties there are, including ones that aren't very good. For example, that's not a very good 2, but it can understand that that is a 2. It's a 2 with a bit of the tail missing, and it can still recognize it. Let's do it once more with another digit. All we're going to do is just change which of these units is on. Everything else stays the same, and we're going to run it again, and the top level there will fall into a different ravine. It'll fall into the ravine for 8s. It's not really in there yet, but it will be about now. It's fallen into the ravine for 8s. And it'll show you all sorts of different 8s it believes in. So this is an example of a neural network that can not only recognize things, it can also generate things. And in the second half of the course, we'll learn a lot about generative neural networks.